In this video, I will talk about how to select the best forecasting method based on your calculations. As of now, you should be able to know how to make a forecast by using moving average method and exponential smoothing method. And remember, when it is time to select or rely on one, how are you going to make the judgment, right? So that is going to be the discussion point of this video. There are many different metrics that we can look at, but the two most important metrics and widely used metrics are mean absolute deviation is one, and the other one is mean square error that we're going to study in this video. So let's get started with the mean absolute deviation, or MAD, as an acronym that we're going to be using to refer to this concept. So MAD is a very basics and very straightforward way of calculating the deviation from your actual values. And the notation is going to be very familiar with you. Remember, A, we use it for actual demand, and F is something that a symbol that we use to refer to the forecast values. So if you know the actual values and if you know the forecast for time periods, let's say, in our previous example, we had the forecast for the first 8 weeks, and we were trying to make a forecast for the week 9 and then later time periods. Well, can we just compare the actual values versus the forecast values for the first 8 weeks and try to see how much deviation we have coming from two or more different forecasting methods, and then select the one that is giving us the minimum error value, right? That's the whole objective here. So whichever error metric, mean absolute deviation or mean square error value that you're going to calculate for a specific forecasting method is giving you the minimum value. That means that that forecasting method is carrying less error in its calculations, and it should be more reliable. That's the whole objective. Okay, so let's try to see how a mean absolute deviation formula work. Um, if you just take a look at this quick calculation method, what it does is, in an absolute value, it keeps the differences between the actual observation for a specific time period and the forecasted value for that specific time period. And what it does, it adds the differences between the actual forecast and actual value and the forecast value in an absolute value. It sums them up across all the time periods and divides it by n, which is the time, the length of the time period, like the number of time periods that we had in our observation. So what am I really referring to do is going to be very clear in the example that's going to follow up. But let's look at mean square error calculations, and then we're going to study the exercise problem together with you. All right. In the mean square error, instead of having the absolute value between the actual and the forecast value for that specific time period, what we do here is we square the differences between the actual observation and the forecast value, and we take the average of the squared differences compared to the absolute value, the differences in the absolute value, sum of them, and dividing it by the number of time periods. And here we do take the square of the differences. So of course, mean square error value is going to produce higher numbers, but of course, you're going to be comparing apples to apples and oranges to oranges, right? So if you compare one method's mean square error value to another method's mean absolute deviation value, that's not going to be fair. So if you are trying to make a judgment between two or more forecasting algorithms or methodologies, you should be comparing their respective um, errors, either MAD to MAD or MSE to MSE, or both, right? So let's study this over an example. In this simple example, we do have 4 weeks of data, and we do have the actual number of permits, City of Lakelands issues weekly, and then their forecast values obtained by using two different forecasts, F1 and F2. Let's assume that forecast one is completely different than forecast two. The mechanism behind it is completely different, and that's why it's producing different numbers. And Mayor of Lakeland is trying to make the best call by selecting one forecasting method, and we are going to be helping the mayor out here. Okay, so one idea to approach this problem is to see what the MAD and MSE values are for each forecast and compare to see which one is producing low error value, and then we will be selecting that one for our to go forecasting method. Let's try to work on it by using MAD. Remember, MAD formula is very simple, starting from t is equal to 1 to 4 in this case. What we are going to do is, in absolute value, we are going to take the differences between the actual observation and the forecast value and divide the whole thing by 4, because we do have 4 time periods. Okay, so let's get started with the forecast one. MAD would be what? It would be looking at, remember, this row keeps our AT, and these are all FT. This is the first forecast, this is the second forecast. Okay, so for the first forecast value, the MAD formula works like this. In the numerator, remember, in absolute value, we do take the differences between the actual observation minus the forecast that we got by using the first forecasting method for the first time period. And we keep doing this for the second one. That is 12 minus 10 in absolute value plus 9 minus 8 plus 14 minus 12, and divide this by 4. The absolute value thing here is going to give us always positive numbers, right? Remember, although a number that comes up negative inside the absolute value will be recorded as a positive value whenever you implement it. So here in this case, it's going to be 1 plus 2 plus 1 plus 2 divided by 4. And our MAD for the first forecasting method should be, looking at the math here, it is 1.5. Okay. And the MAD for the second one can be very easily calculated, again, by doing the same thing. Well, I do have more space here, but I would like to squeeze our entire operation here. All right, let's do it. This time it is 10 minus 11 plus 12 minus 10 plus 9 minus 8 plus, not 8, it is 7. 14 minus 11, and the whole thing divided by 4. And the MAD for the second forecasting method is 2. As you can see, forecasting method 1 is producing us lower MAD value with lower error on average. Therefore, we are more inclined to select the first forecasting method as our to-go forecasting method, right? That is the judgment that the mayor can use. But how about mean square? Let's try to see whether it works out. It works out. It works much better for the second forecasting method. Remember, with MSE, our formula was, again, starting from T1 all the way up to T4, taking the differences between the actual and the forecast values, squaring them, dividing the whole thing by 4, because we do have 4 number of time periods. Okay, so let's start calculating F1 MSE here, what we're going to do is, again, we're going to take the difference here, 10 minus 9 squared plus, there is no absolute value in this formula, but we have to square the differences. And 14 minus 12 squared divided by 4. The result for this equation is 2.5. The mean square error value for forecasting method 1 is 2.5. And mean square error value for the second forecast, let's calculate it. 10 minus 11 squared, 12 minus 10 squared, 9 minus 7 squared, and 14 minus 11 squared. So if you do the math here, you should get 4.5. Well, conclusion is, again, the mean square error of forecasting method 1 is much lower than the mean square error value obtained by using second forecasting method. So much lower. So F1 wins here. And in terms of MAD, F1 wins here. So overall, our conclusion would be selecting forecasting method 1 for our future forecasts. So if you had another forecasting method, if you would be calculating the MAD and MSE value for that one to see whether it is going to be able to beat the F1 value. If not, F1 will still be the winner. Okay, this is how you compare two or more different forecasting methodologies on a problem.